Hey everybody, this is Joe/Foozle CC, and today I'm going to be talking about Construct 3 3D. Now, as you can see behind me in this awesome example posted to Twitter or X.com by Big Soup, this is an awesome retro 3D game running inside of Construct 3. Construct has some built-in basic capabilities like a 3D camera and some 3D shapes. But if you want to do something like this game is doing, you're going to need a few more plugins. And I've talked about some of these plugins in the past, but there's just been some awesome advancements in terms of performance and capabilities over the last year or two, and even just the last few months, that made me want to jump on in and see what I could make using these plugins and share it with the community. So with that said, let's go ahead and jump on in. Okay, so this is the first of two layouts that we're going to show off today before jumping into some of the tips and tricks of these different plugins. But how awesome is this? We've got a 3D world with, look at that, that was awesome, with objects that you can actually interact with now. You've got platforms moving around. We've got this complicated terrain. This was modeled up inside of Blender by Andre Yin. I'll put his link in the description. And we were able to bring this into Construct 3 relatively painlessly and make this kind of all work. So now we've got the ability to bring in three-dimensional terrain objects, put physics on it, and incorporate other objects in the game, detect collisions like this coin that we just picked up, and also add in some cool height-based effects just like this down below. Okay, so this is the first level. Let's go to the second level. Okay, so this is a Doom level, obviously. This is fantastic. This was modeled by Jay, link in the description. But take a look at this. How good does this look? This is inside of Construct 3. You've got height-based fog that's tinted red to make kind of everything glow. You've got all sorts of nice lighting effects kind of going on here in a retro kind of way. We've got some texture normal maps that you can kind of see on the walls here that gives it a little bit of depth. You can play with that to make it look just right for your game. And you could totally make a first-person shooter inside of a game like this. How awesome is this? So I'm going to zoom out and just point out one more thing. If I tap this button, it turns on the debug render view, which is helpful for debugging your collisions. This is the colliders that is inside of the engine. And what's beautiful about this is that we just basically had to set one variable, which we talk about later, and it creates this tri-mesh around the map that we brought in. And this would have been so tedious to do inside of Construct 3 without these tools. But with these few plugins, now all of a sudden we can model inside of Blender a cool world, or you can use another tool. In fact, this was using some Doom level builder, and then bring this into Construct 3, apply the tri-mesh to the collider with the plugin, and you've got all your colliders set up. Okay, let's talk about how we did this and some of the features and go through some of the aces. We won't be able to cover everything, but we'll try to hit on the most important topics that you want to consider when you're using these tools. Okay, so probably one of the first things you're going to do is figure out how do I get a simple model into Construct 3 as efficiently as possible. If you modeled it in Blender, or maybe you have assets that you've downloaded, you're going to want to get it into a GLB format. So bring it into Blender if it's on a GLB format, select the object, File, Export, GLTF. And then let's go ahead and check the selected objects, so it'll only export the objects that you have selected. You can do 10 at a time and it'll all go into one GLB. That can be very useful for big terrains, but we're just doing this one right now. Then let's come into data, and you're going to want to leave your normals on in your mesh because that's going to be useful for the 3D effects, which is one of the plugins we'll touch on. Material, in this case, you want to export it. Normally you do. We'll talk about later, if you only want to export geometry for collisions, you don't need the material, so you can select no export. But most of the time you want to leave export on. And in this case, this doesn't have any animation, so let's uncheck that. Let's call this platform demo and export it. After you export it, I recommend, especially for more complicated models, before bringing it into Construct 3, go use this useful tool, this sandbox by Babylon.js. Drag in your GLB, make sure that it renders fine in here, and it also can give you different stats about what's inside of this model, how many indices and faces, etc. If it works in here, it's going to work inside Construct 3, and this is useful for debugging. Okay, so now we're in Construct 3, and you're going to want to bring in that file so you can associate with the 3D object. So go to Files, right-click, Import Files, drag your file in, hit Import, And now we've got a file in here called platformdemo.glb. You're going to want to add a 3D object and associate it with that file now. So go to your layout, insert new object, 3D object. Go ahead and click, I don't know, here on your map. Let's color it teal. This is just useful for seeing what it is in your event sheets. It won't show up in your game as teal. And you see you don't see anything. That's because we haven't linked the GLB to it. So you go to this GLTF path property, and let's type in exactly as we saved it, platformdemo.glb. If you don't spell it, even with the correct caps, it won't work. So just make sure you link it correctly. Hit enter, and there it is. But it's super tiny, so let's scale it up. This is all just depending on how you're modeling it and what your layout is. But now we've got a scaled up model inside of our game. Let's go ahead and set the Z elevation to, I don't know, something like that. If I hit play and I turn around, there it is. Fantastic. Oh, but I can jump right through it. And as you can probably guess, that's because we don't have physics on it yet. It's just rendering. And sometimes that's all you need. In fact, if you're just needing to render something that doesn't need to interact with the environment, don't put the physics object on it. Let's go put the physics object on this. So you're going to navigate to behaviors, add new behavior, type in rapier, add that. And like we said, it's called rapier because it's based off of the Rapier physics engine. And now if I just were to hit play, let's just see what happens. Huh. Does it work? Oh, what's happening? Well, let's hit P. Oh, it's got a sphere collider on it. Well, why did it do that? Well, it's kind of cool, actually. But inside of Construct 3, if you have a 3D object and you leave it set to auto, it doesn't know what shape it is, so it just puts a sphere on it. But we kind of know this looks like a box, so let's check box. How does that look? Oh, that looks pretty good. That could work. You know what? I might be happy with just that. But maybe it was off a little bit. Maybe some of the dimensions I wanted to override. You can come in here, check this size override, and let's just make it 100 by 100 by 100. That's probably not correct, but let's see what that does. Ah, it makes a box, just like we expected. Probably not what you want, but that's what the collider now is. When you override it, you can use this for tweaking. Now, the last thing I want to show, though, which is very useful for large terrains and sometimes useful for important boxes that you want to have accurate collision on, like maybe a platform, you can come in here and instead of box, let's do model mesh. And if I hit play now, and I hit P, look, it's accurate. And it is basically using the mesh to create a tri-mesh for your collider. Now, what's kind of interesting is, look, I can push this thing around. Maybe I don't actually want to do that. So let's go back. If you see here, it's set to dynamic right now. If you set this to fix, or if you set this to immovable, let's see how that looks. And boom. Okay, it works, just as expected. Fantastic. Now, there's one more property I want to talk about, which is this solid versus sensor. We have it set to solid. Sensor can be super useful for allowing you to run through things so it doesn't collide, but if I still want to detect a collision. So in this case, and this is going to do something kind of goofy, oh look, I'm inside of my head. That's because my character's actually running through this, but I have a camera system set up that if it detects anything between my player and the camera, it goes and zooms in so it can still see the player. I'll demonstrate that with this tree here. So say you moved behind this tree, oh, it pops. There we go. So that's what's happening there. So as you can guess, these coins are set up as sensors, and that's because I don't want it to stop me from running, but I want to be able to detect, hey, I ran into a coin, give me a point, and destroy the coin. Super useful. Okay, so those are the basic properties of the 3D Physics plugin. However, there's a really cool feature that is going to be useful in most games, and that is the character controller. So the way you create a character controller is after the onPhysics is ready, trigger, you can go ahead and assign this character controller. And it comes with all these parameters that you can set. The offset is like giving yourself a little bit of wiggle room for collision around it. So the bigger the offset, it kind of like expands your collider box. Then you have which orientation is up, which is normally going to be Z for you. You have max and min slope angles. This is like sliding down an angle, or how steep of an angle can I run up. And then you can apply impulses to dynamic bodies. And then you can also have this really nice auto step. Like when you saw me in Doom, I could just kind of like run up the steps. That was because I had this auto step checked. And then last is this snap to ground distance, which is useful if you have kind of like a curved surface. It'll kind of keep you on that curve, and a few other things. This is described in detail in the Rapier documentation. It kind of describes what this is all attempting to do. So you can come navigate here and understand a little bit more if you're having trouble wrapping your head around it. Now, that's great, but it doesn't just like allow us to move like an 8-direction behavior. You can't just start all of a sudden use the arrow keys and start moving around. What you need to do is you have to set up how you're going to translate your character controller. So to translate your character controller, you have to use this translate character controller action for the 3D physics. And effectively what you're doing is you're giving it the tag that you set up, and then you're telling it, well, how many pixels in the X, Y, and Z do I want to move this frame? That's what you're telling it. I actually have, a instance variable for X, Y, and Z based off of my input, my WASD controls. I'm computing what my X, Y, and Z should be. And then I also have this ground X, Y, and Z, and that's useful if you're on like a moving platform. I actually raycast beneath my character constantly to tell if I'm on the ground. And I also figure out what the UID of that object is. And if it is a moving body, I update this ground X, ground Y, ground Z, so that my character moves with that moving body or relative to it. So that's why I have two things here. You can make this very simple. You can have just WASD mapped to like X, Y, and Z with a space bar making you jump, and you can change your Z with a tween or however you want to do it. Now let's talk about gravity for a second. So gravity is in the world already for like dynamic objects, but for a kinematic controller like this, you have to create your own gravity. So you can do that in a number of different ways. What I suggest is you have every tick. It can either just be set to a flat value and it's always pushing down, or you can have more complicated controls. When you jump, for instance, you have to let yourself have a positive Z, and then it needs to come back down. So you can do that with a tween, and there's a few other tricks to do that. But that's for you to create. You're in charge of the X, Y, and Z. And the translate is going to allow you to figure out, well, I want to move here, but the physics is only allowing me to go this far, and that's what the physics engine does. So you set up your character controller, and then you just tell it how much X, Y, and Z you're trying to move it, and now you have your player inside of your world. Okay, so that's the physics character controller. I do want to take a moment to talk about performance and some of the things that were done to really help with performance. Okay, so in the past, if you had too many things on screen, it started to eat up a lot of CPU very quickly. But now, McCall has been able to push all that to the GPU effectively and workers, etc., that you can do a ton of stuff performance-wise. But it requires you to set up some things inside of Construct 3 to take advantage of it. So if you have an animated character, what you want to do is after it's loaded, after your 3D object is unloaded, you want to enable GPU skinning. This is going to, especially if you have lots of animated characters, this is going to be an important toggle that you turn on. The second thing that you can do is, if you have an animated character, is that you want to make sure that if we navigate to the player here, in the behavior for the 3D object, you check this worker animation box, and it will push the the animation to a worker, and it will save you on CPU. Backface call is also a good thing to enable for all these things. It pushes it to the worker and it saves you on CPU. Now, if you have a static object, like it's not animated, it's just static, like my two terrain worlds, like the big terrain maps, they're not changing, right? When they're loaded, you want to set static geometry to true, and that's going to save you tons of CPU performance, and it pushes it onto the GPU. So those are two important things you need to be aware of. If you've got an animated character, use GPU skinning. If you've got a static object, use static geometry. Okay, so now we're going to get a little bit more advanced. So inside of Blender, you saw this great big world get created. Let's turn this thing off, and let me turn this back on and zoom out. And there we go. All right, so we've got this great big world that was modeled in Blender. And I'm not going to cover how to model this in Blender. There's tons of tutorials around this. But when you get into this point, you might all of a sudden look over here and look at your stats. And you can view your stats by checking this statistics box. And you're going to want to look at your faces and triangles. So if you're rendering a 3D object, it can handle like millions of triangles at this point. Like it's fine. Like you don't even need to worry about the rendering almost. But if you're going to create a tri-mesh around your level, if I were to just export this and toggle that model mesh we talked about, 43,000 triangles is too many. I would try to keep it below 10,000. So there's some tips and tricks to doing that. Now you could painstakingly inside of Blender create your own simplified geometry, and that could work great. But there's a very good tool in Blender I want you to know about, and that is the UE Collider tool, the Blender Collider tool add-on for Unreal Engine. Well, we're going to use it for Construct 3, but this is awesome. You're going to want to download this zip and install it as a plugin in Blender. Let me show you how to do that. So in Blender, you're going to go to Edit, Preferences, Install, navigate to it, hit OK, make sure the box is checked. Okay, so to demonstrate its usage, Yin had set this nice clip over to me that I'm just going to play in the background. You can see these boards have all this extra geometry, which is great aesthetically, but we don't need it for colliders. So if you hit play, you can see he's using the tool now, which appears over here. He hits this build collider, and it greatly simplifies the geometry. So now instead of having all those triangles for each of these planks, it just grouped them into this more simplified collider geometry. And what's useful is back in Construct 3 is it puts it in this nice new collection. So I can turn all this off and I can turn on my colliders, and I can see I don't have all those complicated boards. I have individual simplified collider geometry, and now I'm down to like 6,000 or 8,000, 8,300 triangles. So that was a huge performance improvement. So you definitely want to know about this tool, and it's going to help you if you've got big levels and you need to simplify the geometry quickly. You can play with the decimate value to try to simplify it more or less. And once it's ready, you just simply select all of the colliders and you go to File, Export, GLB. And in this case, we talked about it, so you don't need animation. In the data, you don't need the material. Select no export because it's just a collider. The physics engine doesn't care about the material, so it'll save you memory. Go ahead and export it, and then you can bring it into Construct 3. So now you can imagine, I actually have two GLB files. I've got the one I'm rendering, and I've got my colliders. And inside of Construct 3, there are two objects. As you can see right here, World Colliders, which has the rapier behavior on it, and then World, which is the actual rendered thing I care about. So if I have any effects, I put it on the render one, like this frag light object. So that's a nice transition. Let's talk about 3D effects. So 3D effects are going to enable a few things, and it can add that extra little touch to your game. You can add 8 lights, is what it's set up for right now, and it's not casting like real-time shadows. It's not global illumination, but it's adding the color to each of the faces inside of your game. So if you've got a light over here and an object over here, and you make this red, this side of the object is going to be red, and it's going to fade, and it's going to look really cool, just like you see in this demo here. You can also do other things with this effect. You have a directional kind of global light, which can be really cool. You can put depth fog, height fog, like we talked about, like we showed in the level. And you can also use the screen door transparency, which is kind of a cool little trick. If you're having trouble with your alpha, it creates like a hash effect. So it's like a fake transparency. Anyways, this is really, really cool. So inside of Construct 3, there's something that you're really going to want to be aware of, is you're going to want to create these 3 families for your effect. Light 3D, Light Object, and Light Sprite. Basically, those are the 3 object types supported that you can apply this effect to. And when you look, though, at the effect, there are like 140 parameters. Each light has like 12 parameters, and there's 8 of them. There's directional light, there's fog, there's, ambient light. There's all sorts of stuff going on here. So it would be a pain to update this every tick if you did not create those families plus this event sheet. So literally just copy all these functions, put it into your project. You're going to want them. What it allows you to do is basically provide the light number, and then you can update the parameters like, hey, this light, if you've got like a swinging lantern and you want to update the position of the light with the lantern every tick, you would want to just call, hey, light number 3, which is my lantern, update to this XYZ every tick, and it will work, and it will make it way simpler. So definitely just copy and paste all of these functions, because these are different light parameters that you have that you can tune, and it will let you more easily manage your lights in your scene. And the other thing I just want you to wrap your mind around, because sometimes this is a little bit difficult, is your, and I have it a little bit challenging here. Let me enable this, and everything's gonna go dark. And that's because I actually have my ambient set to something, I have it set to black because I'm doing some tricks. But let me increase the ambient And okay, now you see everything again. And everything is kind of additive. So if you make your ambient like full on white, you're not going to see your red and your blue and your green because it's all washed out, right? It's already white. Like it's like you can't do anything. So you want to make this somewhat dark in the ambient so that your other colors add to it. That's something that's a little bit difficult to wrap your mind around. I'm doing something a little bit odd where I'm setting this to full on black, and then I'm using the directional light only to kind of light up my world over here. And then this next thing I have, which is a little bit of a trick, is you can set your brightness to a negative value to create a shadow light, which is what I'm doing inside of my world when I run around and jump underneath my character. You can see I've got this shadow underneath me, and I'm updating the position of this every frame. And it is aimed right beneath my character, and I'm toggling a few different parameters to kind of make it attenuate appropriately as I jump up and down. But that's something that you can consider, is if you want to make a shadow light, you can use negative brightness. Okay, so at this point, I think I've covered what I consider pretty essential items, but I'm going to cover now a handful of other features that are packed into these gems that I want you to be aware of. The first that I'm going to talk about is the ability to change your material in the game, which can be super useful. So imagine you've got these different textures that are different skins, or maybe you have different color themes for different teams. You can use the same model, but like Team Red gets this one, Team Blue gets this one, and you can update it inside of your game. So, and you can do this by node. And inside your GLB files, there's these groupings called nodes, or effectively you can have, for each mesh, you can change it. So if you just want the shoulder pads to change a certain color, you can change the shoulder pads. This is pretty cool. The next thing I want you to be aware of is that 3D physics works with sprites. That's awesome. So you can even do 3D mesh displaced sprites. So if I go ahead and hit play on this, this is a distorted mesh. I can start dropping objects onto it, and look at how cool that is. That's awesome. So you can do some cool stuff with this. You can use sprites with the physics engine, and you can even do a 3D mesh, and it will work. All right, now we're gonna talk about joints. There are currently 2 joints added into the plugin, a revolute and a sphere joint. But how cool is this? I mean, I'm tempted to want to try to make like a ragdoll almost using, I can even move this little dice around. I didn't even know that. So, I mean, that's awesome. You've got joints in here. You can make some cool like 3D rope stuff. I don't know. Feel free to let your imagination run wild. I already touched on the Kinematic character controller, but my code is very complicated, and I acknowledge that. So I want you to be aware that you can go download this inside of the physics itch page. This is a 3P file you can get, and it shows a really simple way to start off with implementing your player controller. And you know, it demonstrates pretty quickly the whole like, hey, I can run up this slope, but this slope is too steep. It won't let me. So be aware, there are simpler ways to just right off the bat with only a handful of event sheets, get yourself up and running with a character controller inside of your world. Okay, and this last one's a little bit more complicated, and there's a couple aspects to it. We're going to talk about shape and raycast, and then also filtering groups. So shape casts and rape casts are basically the same thing, but it lets you shoot from a position to a position, and it will detect collisions along the way. And if it's a shape cast, you can actually cast like a shape. It's not just a line. Like you can cast a sphere or a box or a capsule currently. And it will return all that information. I'll show you what that looks like in a second. But what you can do is it triggers when it gets the result, this on cast shape result or on raycast result. And you can just set it to a JSON object inside of Construct 3. That's my preferred way of doing it. Now, if you look at this demo project, which you can download, it demonstrates what this looks like. So it actually visually kind of shows it. Let's say I want to trigger a shape cast. It triggers and it hits this 0x0100. And that's because I pushed the 0x0100. But what's happening here is that when you do these shape casts and raycasts, you can insert a filter group. And when you create objects and you add them to the physics engine, you can assign them to different filter groups. So in this case, each of these boxes were assigned to the 1000, the 0100, the 10, and the 1. And you might have different aspects in your game that might trigger you to think about how you might want to do this. For instance, in my game, I have a specific group for everything that I want to collide with the camera. I have that in a group. And everything that I want to be important to me for movement, I have that in a separate group. And that allows me to have, when I do my raycasts or my shapecasts, only give me collision results that are in that group. Ignore everything else, which is super useful. And I know it's using these complicated 0x1000 and 0x0100. I would recommend taking a look at the Rapier documentation, which I'll link down below, and it will describe some of this. I will confess, a lot of times, if it gets more complicated, because there's ways that you can do like this or this group, all in the same filter group for how you set up your raycast, I just asked ChatGPT, like, okay, I have these 3 groups that I want it to be able to hit. What is the appropriate hex code? And it will be like, oh, it is 0x0f2, or I don't even know. And then I can put that in. But if it's very simplistic, it's just one-to-one like this, it will hit the appropriate one that you want it to hit and ignore the other groups. And it returns the information looking like this. So the one that you're going to be most interested in is this hit point world. And first of all, and has hit, is it true or false? If it does have a hit, maybe you do something, like maybe you put an explosion at this XYZ point in the game. So this is probably the most complicated aspect of trying to figure it out. Feel free to dig into the documentation and explore these examples in a little bit more depth. Okay, everybody, and that is Construct 3 3D. Kinematic Games is actually going to be running a discount over the next month on the 2 paid plugins, which is currently Physics and 3D Effects. I think you can get both of them for $8. Normally they're like $10 each, so grab them over the next month while it's on discount. And thank you to Kinematic Games for making these awesome plugins. Also, special thank you to both Yin, who made the level in Blender, and Jay, who made the Doom level. Those were awesome examples, and I really appreciate you letting me share them with the community. And with that said, if you enjoyed this video, give me a thumbs up, subscribe to this channel if you enjoy content like this, and good luck in your game dev journey.